Slooh is your interface to space. Online telescopes situated on mountaintops around the world await your command to schedule missions so you can capture images of the 1,000 most intriguing celestial objects in the universe. From just $20 per year. Slooh is your interface to
Hey everybody,
space.
this is Slooh. I'm Bob
Online
Berman, your
telescopes
pal,
situated on mountaintops around the
I've
world
been with Slooh
await
for
your
more
command
years
to
than I
schedule
can count.
missions so you can
We're
capture
almost growing
images
old
of
together.
the
But
1,000
tonight
most
we're doing the moon, and the moon,
celestial
you'd
objects
think,
in
oh,
the
come on, the moon. With telescopes like Slooh's, with this kind of amazing equipment, you'd think, well, it's got to be for black holes or for quasars or something esoteric. But the fact is, the moon has more detail, shows more detail than any other celestial object. And no matter how long you've been observing it, there's still something new. Here, I just found this old image. I just put it in a frame. This is a pencil sketch that I made at the eyepiece when I was 14 years old, 14 or 15, of the crater Copernicus, which will be out tomorrow night. And maybe the sun is just starting to hit it tonight. We'll have a look. And so it's always fascinating. The moon is great and forgiving of bad equipment, but when you have good equipment like what we have tonight, wow, it's so much fun. And here's something else. Whatever happened to the moon, and you could see it was violent. Look at this violence. It just shows it kept getting hit. Bam, 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 bam. Was also happening to Earth at the same time because we're 81 times more massive. We're 4 times the diameter. So all the debris back in those days of the Wild West of the solar system, 4 billion, 4.5 billion years ago, 4.2 billion years ago, when most of these craters were formed and all this damage was done on the moon, same thing was happening to the Earth. So we're getting a little microcosm of our own past geology when we look at the moon. So there is so much, it's a storybook, so much to see. For example, right now, the reason it's called the International Observe the Moon Night, all around the world, people are observing the moon. People don't usually have telescopes like the Slooh telescopes here at the Canary Islands, but wow, all around the world, telescopes are looking at this, and this is the night when the lighting is the most perfect. Why? Because the sunlight is coming from the right, so all the craters and mountain ranges that are running down the middle of the moon are being lit up from the side, and that shows all of their detail. Like, look on the right side of the moon. You see darker areas and lighter areas, but do you see any holes, any craters, any mountains? No. But I tell you, there are just as many craters and mountains there on that right side of the moon as there are in the middle. So if there are just as many, why don't we see them? The lighting is the key. At full moon, the sun is shining straight down on the moon, washing away all the detail. Full moon, you don't see anything. Experienced observers never look at the moon through a telescope, but the quarter moon, which is also called the half moon. How do you like that? Only in astronomy does half and quarter mean the same thing. We're a little crazy, we astronomers. Well, anyway, the first quarter moon or the half moon, or even the last quarter moon, which is also called the third quarter moon, which was also a half moon, that's when to look at it. And that's when we are. That's what's happening tonight. I know we're going to be joined by Paul Cox, who really runs the equipment here, and we're going to be hearing from him soon. But until he does, let's dive right in and look at some lunar features. First of all, there are those dark blotches, which were all lava flows. Yep, back when the moon got hit with really giant asteroid impacts, most about 4.1, 4.2 billion years ago, in a period called the pre-Nectarian and the Nectarian period, those basins got filled up. Look at the one on the right. It's a pretty close to perfectly round, a little ragged on the edges, but round basin called Mare Crisium. Mare means ocean, sea. It's a sea because early observers thought they were looking at bodies of water here. And Crisium means crises. It's the Sea of Crises. That doesn't sound like fun. But it turns out in naming the moon, all of those dark blotches or seas were named after one of two things, either human emotions or weather phenomena. They don't even go together. So that dark round one on the right is Mare Crisium. Just to its left, that big kind of irregular on the edges blotch. The biggest of those blotches is the Sea of Tranquility. Yep, where Apollo 11 landed. And that's Mare Tranquillitatis, because the Latin is used. And then right above it, almost like an hourglass form, or the number 8, or snowman, if you want to see it that way. That second ball that's balanced on top of the Sea of Tranquility, that's the Sea of Serenity, Mare Serenitatis. So you get the idea. These are all named for different features, different oceans and seas and things like that. Also, on the left side, you can see the shadow line, the left side of anything you can see on the moon. And that shadow line is called the Terminator. I know everybody loves that. The Terminator, the line separating day from night. And that moves along the moon's surface at about the speed of a jogger. If you jog, I don't know why anyone would want to jog. You know how joggers, like the famous Jim Fixx, who wrote books about like everyone should jog, they all drop dead. Why jog? In any case, you jog at about 10 miles an hour, and that's the same speed that Terminator slithers over the surface of the moon. So that tomorrow night, that day-night line is going to move to the left by 10 miles per hour, 24 hours in a day. So it's going to move about 240 miles. Now, the whole moon in diameter is 2,160 miles. So you can see it's going to move more or less 1/10 of the moon's visible disk per day. And as it does so, it lights up new things. That's why the moon is always fascinating. There's always something new to see, because even if last month the lunar terminator was lighting up a crater pretty much the same way it is now, it's not exact. It missed it by a few hours, and that's enough to make the sun a little higher in the sky or lower. Let me give you real figures. Right along the terminator, right along the day-night line, a crater that's visible right there has the sun about 20 degrees high in their sky, about as high as our sun is an hour and a half or 2 hours before sunset. Picture that. Picture how high the sun is an hour and a half, 2 hours before sunset. That's how high the sun is in the lunar sky right now for craters on the Terminator. Well, let's talk about craters. Look at the top now, the very top of the moon, at the two most prominent craters, a bigger one above and a smaller one just below it. And the top one is Aristotle, and the one below it is Eudoxus. And this is the first of getting the idea that craters were named for famous people, especially in the sciences or in math. And so they've been honored, immortalized by having craters named after them. Or mythologically, if you look to the right of those two craters, more into the sunlit areas, there are two other craters side by side, and those are named after mythology. The one on the right is Atlas, and one to the left is Hercules. So those are like the strong guys. All right, looking down from those first two craters that I pointed out to your attention, that is Aristotle and Eudoxus, look how a mountain range starts. Just below them and to the left of them, do you see that mountain range, one after another high peak? That's the finest mountain range on the entire moon, the lunar Apennines, the Apennine Mountains. And if you start observing the moon every month with a backyard telescope, or here at Slooh, or have a mission where you yourself go to the moon and observe it, you're going to love those Apennines, because they show a lot of detail. Hey, here's another view. This is now like a higher power zoom in view, and we're looking at it from a different angle. So those
video.
So we're looking at it live now. Look at the left, and there are those two craters. The one on the extreme left is Aristotle. The one to its right is Eudoxus. And then there comes the lunar Apennines curling around, a curving mountain chain, the finest chain in the entire moon's surface. So right away we see kind of the history lesson. And this is what's so fascinating. You don't need to read a book. You can see what happened to the moon. And remember, it happened to Earth at the same time. The oldest features are the ones that are, well, let's talk about those smooth seas, the mare, those dark areas. They have no craters in them, by and large. There's a few. We'll get to those in a moment. And that means they covered up the really early stuff. So the earliest features on the moon were drowned out by flowing lava, which is now smooth and dark and form those blotches. We've already seen the blotches that are the Sea of Tranquility and the Sea of Serenity, and on the right side, the Sea of Crises, Mare Crisium. And very cool. But what happens if you see a crater inside that smooth lava area? Well, then that had to be more recent, right? Because the lava flowed over the earlier stuff, and a crater on top of the dried lava must be the really young stuff. So look between those two main blotches. Remember, I said near the middle of the moon, there are the biggest dark blotches form something that looks like a dark snowman or figure eight shape. One of them being the Sea of Tranquility, and the top one being the Sea of Serenity. In between those, where they join, the sort of narrowing where they join, there is one really clear crater. Can't miss it. That's Pliny, named for Pliny the Elder, the famous book writing historian back in old Roman times, Pliny. So you see, these are all named for historical people, especially eggheads and nerds and science people and mathematicians, and we got some writers in there too, all named for the for the moon. And I know I'm babbling on about this, but it's so exciting. The moon just never stops giving you detail. We're looking live now at it, and joining the world on this explore. No, it's called Observe the Moon Night internationally. Set up in September, because in many parts of the world, September is a clear month, and also because the first quarter moon, the half moon that's lit up on the right, that's what we're seeing. The half moon lit up on the right is the first quarter moon. There's an extra bonus too, and that is this is the phase of the moon that's out as soon as night falls and is at its highest point in the sky, conveniently located at dinner time, supper time, nightfall. So wherever you are in the world, if you're in a place where the sun is still shining, I am, and if you're in California or Hawaii, the sun, wow, it's the middle of the day, still there. But wait till nightfall and you'll see this. You'll see the half moon lit up on the right at its highest point of the entire night, just then at nightfall. So happens at this time of year, the first quarter of the moon isn't high up at all for people in the northern hemisphere. So when I say highest of the night, don't look right overhead. It's actually hanging out in the constellation of Sagittarius, and that's the lowest part or most southerly part of the zodiac. So it's sort of low in the south. That's where you have to look for it. Although, why am I telling you how to look for the moon? If you can't find the moon on your own without someone saying, that's the moon there, then we got to back up more than just into astronomy, don't we? Because the moon is the only object that everyone in the world can recognize. So let's get more into the features. The earliest moon, again, had features that were formed 4.2 billion years ago, like that. We call that the pre-Nectarian period. Then came the Nectarian period, and then the Imbrian period. Mare Imbrian is going to show up tomorrow as that Terminator slithers to the left at 10 miles an hour and exposes it. And then came a period named for a great crater that I'm sorry we can't quite see, but the sunlight is not yet exposing it. Tomorrow night it'll be beautiful. It's Eratosthenes. He's the guy, the librarian in Alexandria, who first told the world how big Earth was. Imagine that. Correctly. He's the first person who said that our round planet Earth was 25,000 miles in circumference. He used He didn't use miles. They didn't use the figure miles then. They used stadia, but that's okay. And he did it without ever setting foot outside of Egypt. How the heck could anyone figure out the true size of Earth without even traveling, without ever being outside of Egypt? What a guy. That was Eratosthenes. So one of the finest craters is named after him, and a whole lunar epoch, a whole lunar period is named after him. It's called the Eratosthenes period. And then after that came the most recent one that started only about 1 billion years ago. That's the Copernican period. And that was when the newest stuff on the moon formed. Want to see stuff from the Copernican period? Well, Copernicus itself actually was very recent, but it didn't happen at the time that the Copernican period began. But when you see craters that have hit other craters, well, they're obviously the newer craters. You can't have an older crater making a hole in a newer crater, can you? Duh. So any craters on top of craters are new stuff, and craters on top of those dark lava smooth areas is new stuff. Another mark of newness are some of the ray features we see. I'll show you one of them. They come up more and more as the moon waxes and comes closer to being a fat gibbous and full moon. You'll see extensive rays, some of them extending as far as 1,500 miles, especially from the craters Tycho and Copernicus. But there are others too. Look on the right side of the moon now at that really almost perfectly round dark blob. That was Mare Crisium, the Sea of Crises. Remember, they're all named after emotions or weather phenomena. So that's the crises in your life. If we don't get Paul back here, who runs this thing, you're going to see some. I'll be having some crises myself, and see it's appropriate that the moon's named for this kind of thing. Anyway, there's Mare Crisium, or Crisium if you prefer, that dark blotch on the left. Now look on its left side, and you'll see probably the whitest spot on the moon right now. See what I'm talking about? Just on the left side of that perfectly round, dark area on the right side, just on the left side, there is a brightness, and look closely and you'll see rays, straight lines, emanating from that bright spot. And if you follow those rays to the right, to the upper right, even a little bit to the left, you'll see that it's a small ray system, but very distinct. That's the crater Proclus. And the rays are typical of what happens in the more recent history of the moon when the moon gets pounded. So, wow, a lot of stuff to pick up, including its history, the chronology of events, just by making simple observations. Another one we're making is that look at the color. Now, this is true color. This is a live image in true color. And yet we don't see any color, do we? It looks like it's a grayscale image, a black and white image. So what's going on with that? Well, let's play detectives. If the moon is showing no color, essentially the whitest features are just white, and if it's covered with powder, which it is, we found that out from the Apollo astronauts. Remember, their footprints showed up nicely because it was a very fine powder. Well, what do you think the surface is made of? It has to be whitish. It has to be cheap, because otherwise we would have gone back to the moon, wouldn't we? If the moon had diamond dust or something like that on it, or refined uranium ore or something that we could use. So something inexpensive and whitish covers the entire moon. It's called regolith, and it's a very fine powder, like baby powder. It's not baby powder, but it's as fine as baby powder because of micrometeors that have been pounding the moon like the hammers of Thor, pounding the moon for billions of years until everything on the surface is just powder. Unless you're a big rock to begin with, or a mountain, you're going to end up as powder. And so, all right, I'll tell you. What it is silica, sand, essentially, SiO2. the same stuff as quartz, same stuff as beach sand, except pounded by hammers finer and finer and finer until it's really soft. And it's stinky too. It turns out as they brought the material onto the Apollo spacecraft to take it back, it smelled bad. It smelled a little like gunpowder, but worse. The guys, the astronauts at first had to really think about this. What's making that smell? I mean, remember, they were living together, these guys, for day after day. Was it you? Is it you? No, it was the moon itself. The moon has a smell to it, not a pleasant smell. Well, the moon also did something else strange when it was hit. Whenever a giant meteor has hit the surface, we left seismometers behind, so we know this for a fact. Or when we sent an unused part of a spacecraft, like once the astronauts had transferred into the command module, they sent the unneeded lunar lander, the ascent stage, crashing back to the moon's surface, so that an object with a known mass and a known velocity would make the moon tremble, and we had seismometers to measure it, and it would tell us what's under the surface. That's just what we do on Earth with seismometers. We create deliberate thumps or explosions, and the way they propagate underground tells us what the substance is under our surface. Same thing with the moon. So when that was done, we found that when the moon is struck, it starts shaking, vibrating, vibrating, and the vibrations after a minute kept going, and after 2 minutes, and that was strange because on Earth, the shaking from earthquakes and things dies down in a minute or two. No, on the moon, after 2 minutes, it was still going. 3 minutes, 4 minutes, an hour, and the moon is still vibrating like a giant gong, as if somebody had hit a gong, like that. An hour and a half, the moon kept vibrating whenever it was struck. So that tells us something about its interior. Specifically, it must have a solid core. The moon is only 1/4 our size. We're about 8,000 miles in diameter. The moon's 2,160. And we have a liquid outer core. We have a solid inner core, but a liquid outer core. And that doesn't let vibrations pass through. Liquid is not a good transmitter for vibrations. But the moon, obviously, must have a solid core so that those impacts, those vibrations, kept propagating through the moon, vibrating for almost 2 hours. Wow. So moon's full of surprises, many of which we've gotten only in the last, let's say quarter century or so. Certainly going there between 1969 and 1972 helped a lot. Analyzing the material, look what we're looking at. Did we find things that were really alien? No, not really. You know, half the moon is made of one element. Give you $1 if you know what element the moon is mostly. I wish Mike were here. Mike, who is so dedicated with Slooh and has been running this company since the beginning. What's
carbon?
Carbon, he guesses. No, nobody guesses it right. The moon is more than half. It's more than anything else. Oxygen, which is the same thing as animal and human bodies, by the way. We are, by weight, we're more than half ordinary oxygen. And the moon, it's not a gas like here on Earth we're used to, oxygen being in the stuff we breathe, but on the moon it's in a solid form like silicon dioxide, SiO2. And all of its elements are bound with oxygen. The iron is bound with oxygen, and the magnesium dioxide, silicon dioxide, everything is mixed with oxygen. And since I said animals too are more than half oxygen, you know, whenever coyotes or wolves howl at the moon, essentially what's going on is oxygen is howling at oxygen, really, in this part of the solar system. So think of the moon as being like made of friendly stuff, made of materials that we're accustomed to on Earth, but in a form that's strangely like our planet Earth. Really
Hey,
strange.
Bob, take a little wind down break.
Okay, what we're going to do is I'm going to take a little break here, and then we're going to come back as we explore the moon on International Observe the Moon Night. Live images of the best possible time to be looking at the moon's features. That is the first quarter moon. That's tonight. That's what we're doing. I'm Bob Berman, and this is Slooh, and we'll be back in just a little bit.
Slooh is your interface to space. Online telescopes situated on mountaintops around the world await your command to schedule missions so you can capture images of the 1,000 most intriguing celestial objects in the universe. From just $20 per year. Slooh
Hey everybody, Bob Berman. I'm back with you. This is Slooh, and we are participating in the International Observe the Moon Night. We've got a great night. We're using the Slooh telescopes. Overkill, really, because the moon is one of the relatively few objects that looks pretty good through a backyard telescope, anyone's telescope. So with the Slooh telescopes, wow, we're seeing exquisite detail. We were just talking about that for the first, half an hour or so of this show. Now we're going to switch gears a little bit. We've got Helen Avery on. Now, Helen is an expert in mythology and old things and lore, legend, and things like that. And what I'm interested in are the moon maps. The first person to see the moon through a telescope was Galileo in 1609. And but before him, there were even people observing it and mapping it. So, Helen, tell us about this.
Yeah, I mean, the first, as you said, like the first maps we think of the moon were at the dawn of the telescope, really. But there are some sort of theories that it was mapped a little bit before. One is, and it's very random, but it's at Newgrange, well, not far from Newgrange in Ireland, at the Neolithic sort of monuments to mark the solstices, equinoxes. There's a mound of, it's called Nauf. I'm probably pronouncing that wrong. I went there earlier this year, and there are lots of these spirals and circles that people say are the moon, and some of them have strange markings on within the spheres that people say were actually people sort of drawing in the dark spots that they saw on the moon. So that's like 4,800 years ago. And you've got to think, as you say, like it's such an obvious thing in our sky, and you can see the dark and light patches. I mean, think of the ancient Chinese with their drawings of the rabbit and things like that. So they weren't really mapping the moon, but they were certainly starting to draw the moon many, 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 many years ago. But then, as you mentioned, Galileo obviously is the one we think of first with the moons. But there is a gentleman called William Gilbert. Do you know about him?
No, I don't.
Oh, so he actually died in 1603 of the plague. He's from my county, Essex in England. Actually, he's from Colchester, and so before there were telescopes, he did do some drawings of the moon that weren't discovered till much later, actually. But they think actually, so William Gilbert was the first to kind of start the formal mapping of the moon. He started sort of drawing the dark shapes and trying to name them. And interestingly, he was the gentleman who came up with the term electricity, and he discovered magnetic laws. So it was quite an interesting chap. So they say he beat Galileo to it. And then there's also Thomas Harriot, who was also a Brit.
He was famous because he competed with Galileo for some years.
And they say
especially
he
in observing
mapped it
the sun.
first.
Yes.
So they say 3 months before Galileo did his wonderful drawings, those 3D drawings of the moon, this Thomas Harriot, who also sailed to the Americas and learned some Native American languages. I didn't know this in my research. He was a really interesting man. But they say that he also started mapping the moon a little with a telescope before Galileo. So I don't know.
Now tell me if I'm wrong, Helen, but if I remember about him, and tell me if I'm mixing him up with someone else, he came back from his fascination with Native Americans with their with the fact that they smoked tobacco. He brought it to Europe, claimed that this is marvelous stuff, marvelous for the health, started smoking tobacco himself, introduced it to others, and sure enough, died of mouth and throat cancer.
It did. I read nose, but it was because of the tobacco. Yeah.
Yes.
It is, and he's also credited with bringing the potato to England.
Yes, and less untoward consequences came from him bringing.
It's true. Potato. It's true. Yeah, and then of course there's the dawn of the telescope era. So then everyone starts mapping the moon. You have Michel Florent van Lingrans. I'm going to get his name, pronounce it terribly, but he was a Belgian, and he did some mapping of the moon, and he he named some of the parts of the moon after Catholic monarchs and saints, and so some of those got scrapped over the years. And of course, we have the wonderful Johannes Hevelius, who's one of my favorite astronomers of all
Yes.
times, and his wonderful selenographia, his mappings of the moon. And some of his names remained, not all of them. You were talking about some of the names earlier, and some of those were kept, like his Alps. But I gather he got quite complicated with his swamps and his marshes as he was mapping the moon.
Now I have a question for you, because when we talk about maps, the basic question is east, west, north, south. That's the the 101 course on map making. Now the International Astronomical Union, the IAU, established some guidelines back a few decades ago that has pretty much been adopted by some, ignored by others, and simply put, when we see the moon in the sky, north is up, south is down. But now, what about right and left? Tonight, when anyone looks at this moon in the sky, all they have to do is step out at around nightfall. The right side of the moon will be the sunlit side, and closer, of course, to the west. So, for years, many would call that the western side of the moon. Mare Crisium there, that big dark, that small dark round blotch, would be the guideline. That's defines the western edge of the moon. The left side would be the eastern. But as I understand it, people didn't like that, because on maps on Earth, you don't have west being on the right. You have west being on the left of earthly maps, if north is up and south is down. So because of that, as I understand it, people to this day are using contradictory systems. And that's one of the reasons I avoided when I was talking about lunar features. Notice I didn't say, look at Mare Crisium there on the west side of the moon, or I don't dare say the east side of the moon. Do you have a position on this?
I have to confess, I have never thought about it. But as you're saying it, yeah, it's confusing. I would call it the west side of the moon.
Yeah,
I would call
because
it
it's
the west side
closest
of
to
the moon.
our western horizon when we look at it.
Yeah,
Yes.
yeah.
Ah,
So I have a question for you. So there's a lot of discussion that Leonardo da Vinci actually started mapping the moons, and it's apparently just an urban legend. But he was quite obsessed with the moon, and he was the one who posed the theory of Earthshine. And so I started having a little look at Earthshine, and it's incredible. So, but you would be able to explain it far better than me.
yes. Well, Earthshine is when we don't really see it very much right now when we're looking at a half moon like this first quarter moon here. But it really stems from the fact that the Earth and Moon have complementary phases. So that whatever the moon looks like, the Earth is the exact complement. Meaning, when the moon appears as a very thin crescent, that's exactly when, if you were on the moon, Earth would look as a very fat gibbous, almost full. And when the moon is blank, is black, is new moon, can't be seen, that's exactly when, if you were on the moon looking towards Earth, Earth would be full, the opposite, brightest when the moon is dullest. And so these complementary phases means that whenever we look at a very thin moon in the sky, a little thin crescent, that means everyone on the moon is seeing a very nearly full Earth, a brilliant Earth. Now, Earth happens to be over 50 times brighter than the full moon looks in our sky. So it's brilliant.
No.
And it floods the lunar terrain with Earth light. And that's what we see whenever we see what they used to call the old moon and the new moon's arms. And there's different ways of expressing this. In other words, a glow on the dark side. So we'd see the bright crescent, and then the dark part of the moon still is glowing pretty prominently. Well, that's Earth shine. That's our own light hitting the moon because of that complementarity of phases. The fact that we are then nearly full for citizens on the moon, namely Noah.
And is it, I mean, what causes that brightness? Is it like just a reflection of the clouds? I mean, what is it? Is it just
Well,
the
it's
sun
sunlight
bouncing
hitting
off?
Earth. It's actually
Mm.
sunlight taking a bunch of bounces, because it's sunlight hitting Earth, bouncing off Earth, and we are quite reflective. The moon's average reflectivity, called its albedo, is only 11. on average, the moon only reflects about roughly 10% of the light that hits it. We reflect 38% of the sunlight that hits us. Cloudy regions, of course, are even more reflective because clouds are bright. But all in all, we reflect 38. So we're not only bigger in the lunar sky than the moon is in our sky, but we are much shinier than the moon. So we are brilliant, and we light up the moon's dark area, that is the area that's not directly sunlit. Or put another way, it's sunlight hitting Earth, bouncing off Earth to the moon, and then bouncing off the moon back to our eyes so that we're seeing it. So it's sunlight that's taken a three-way bounce. That's what Earthshine is.
I love that. Oh, oh, look, and then here
Look
we
at
go.
this. We're back to live video feeds of the moon. We're looking now at the southern Highlands, by the way, the section of the moon that is among the oldest areas of the moon. This is a region that is, you can see, heavily pockmarked, and because it's a little higher up than the others, lava has not flowed there and washed away the oldest craters. So we're seeing some of the earliest damage and the earliest violence on the moon in these southern highlands section, beautifully lit up at this time of month.
So I was under the impression that since Johannes Hevelius mapped the moon, there really haven't been many changes. I don't know how we would prove that. I mean, unless you're constantly looking at
Yes,
the
well,
moon, but
because
what's your understanding?
well, astronomers occasionally see flashes on the moon showing that impacts still happen, but this is no longer the Wild West years. You know, back soon when after the moon was formed by the collision of a body named Theia. It's dead. The body disintegrated. It was a Mars-sized object that hit the moon. That's the probable origin of the moon. When Theia hit, uh, took a piece of Earth. There was a collision with Earth and threw off material, and some of this condensed to form the moon. But ever since then, smaller things have hit the moon. You can see it. Look at this history of damage. And as a result of some of these impacts, lava flowed. Not today. There's no longer, we don't think, a hot interior to create lava, but all those dark, smooth areas are all flowing lava fields, and all those holes are once there was a debate back in the 50s and 60s as to whether they were volcanic in origin, the craters, or meteoric in origin, and we now know they are all meteoric.
Mm, yeah. And in terms of sort of more modern maps, really, like, the geological maps of the moon began when we started sending probes to the moon. And I was just sort of doing some research and reading about how, I mean, they had to know what the moon looked like, because if you're going to send people to the moon, you had to make sure where you were landing, there wasn't going to be a massive hole or a sea or some sort of mountain that they were going to land on. Just kind of incredible to think that they were able to do that with such accuracy and find a place that they could land.
And that's what we're looking at. Actually, the very center of our live image here is the Sea of Tranquility. That is where Buzz Aldrin and Neil Armstrong set down on that date, on July 20th of 1969. You can see how smooth it is. You can see that it was chosen because, since it is solidified lava, it looked like it would be safe. As it turned out, though, as Neil Armstrong was about to touch down, there was a boulder field that he had to fly over before he found a really suitable place. This would have killed them, because if they had landed with one of their legs on a significant rock or boulder, it could have tipped over their craft, and they would have never been able to leave the moon, or put it at such an angle that departure would have also been difficult. So good job.
Yeah. Oh.
And so Helen, this is really amazing. I led off by saying that the moon is forever fascinating, shows more detail than any celestial object. And even when you have at your disposal telescopes of the astonishing quality of what we have here at Slooh, and you'd think that, oh, the moon is so nearby, it's only 250,000 miles, and we've even been there, and why waste time with the moon? But no, it's got more detail. And it changes more by far. than any other celestial object. So I don't know about anyone else, but I'm not even close to being tired of it after over 60 years of observing the moon at every opportunity. It's still fascinating, and I hope a lot of other people feel the same way, because maybe we'll do this again here at Slooh, even when it's not the rest of the world doing it with us.
Yeah, it was the first object I ever saw through a telescope. It was just a telescope an old boyfriend bought me, for Christmas. It wasn't anything fancy. Not to disrespect him, but it wasn't anything fancy. And I remember setting it up with my dad in the garden and looking at them, and it was it was already on a crater, and I was like, what on earth is that? And I just couldn't believe it. And from that day on, I'm just kind of obsessed with the moon, really. It's just incredible that we get to look at it in such detail.
Do you remember the phase of the moon at that time when you saw it the first time?
I don't even think I'd have known there were phases of the moon at that time. I was a complete fraud. I just wanted a telescope to look cool, I think. No, why? Tell me.
And the first name of that boyfriend was what?
That I do remember.
And you do remember?
I do remember his name, yeah.
Oh, okay. All right. Well, on that note, I guess we'll wind this up. This has been a lot of fun. And let's do the moon again sometime. Thank you, everybody, for joining us here at Slooh on this international Observe the Moon Night. And that's exactly what we've done. Hope you've and there's more coming. We're not finished. So stay tuned.
Stick around.
I'm Bob Berman. This is Helen Avery, and this is Slooh.
Hello, everybody. I've missed a couple of Slooh shows in my life, but I've never actually missed one that I'm meant to be hosting before. So, huge apologies. 1 minute before the show was due to start, I'm sitting in Dome 3 and everything went quiet. And I couldn't hear or see anything in Dome 1 or 2. Our main UPS, you could not wish or for or have a more important piece of equipment go wrong, but the main UPS went down, and then of course I'm in the dark, so I've just had to kind of cobble everything together, hook things up temporarily, bypass the UPS and stuff like that. But I'm here now. Hopefully you have been enjoying some of the earlier views that we had, and I know you will have enjoyed Bob Berman, the encyclopedic Bob Berman, and I believe you've also heard Helen Avery as well, but of course I haven't actually been watching the show. But anyway, down here, joining me now is Dr. Mike Shaw, leader of the Nightscape Club. Hi, Mike, how are you?
Hello, Paul. It's great to see you. It looks like you're sort of a disembodied head floating in the darkness, but I'm glad you're here. Congratulations for figuring it out.
Well, thank you very much. And I'm at our Canary Islands observatory at the moment. As I say, I'm in Dome 3. And what we're looking at now, I don't know what you make of this, Mike, but this is the Canary 4 solar system telescope. But instead of our CCD camera on the back of it, just to prove that it's actually video, I'll move it a little bit. We've actually got a special mirrorless camera connected, video camera connected to it. What do you make of these views?
Fantastic, Paul. Well, I tell you that we've just been listening to to the encyclopedic Bob Berman and the encyclopedic Helen Avery, giving some tremendous descriptions of Mare Crisium and the Sea of Serenity and the Sea of Tranquility and the Apennines and the various craters that we're looking at, the Highlands. And these views are marvelous. I just couldn't be happier to see them, and I couldn't be happier to see you in terms of the various aspects of the moon. And the camera's doing a marvelous job. Oh dear, Paul, I don't know if you're still with us, but nonetheless, we'll just wait and see. But yeah, so the goal of I'll just keep going, and hopefully we'll have Paul. Looks like Paul has disintegrated into a bar of colors, but I'll just keep going. So as Paul mentioned, my name's Dr. Mike Shaw. I'm the host of the Nightscapes Club on Slooh and the author of a couple of books on night photography, and it's a real pleasure to be a part of the Slooh team on these occasional shows and then a weekly audio live cast. So you're all welcome to join in. But tonight, as we're celebrating the International Observe the Moon Night, it really is a special treat, as Bob was mentioning right at the kickoff, when around the world, this is an event that everybody can appreciate just because of the commonality of the shared experience with the moon. And as Bob was pointing out, the fact that it's the first quarter of the moon when it's half illuminated is situated perfectly in the southern part of the sky, high up, where everyone can see it. It's visible right at the moment of even before sunset. And as you know, as Paul was just, I think, having the chance to mention, my specialty is really in photography, astronomical photography. But the real subset of this would be what we like to call nightscape photography. And nightscape photography it's kind of a combination of deep sky photography with landscape photography, which is why it's called nightscape. And so you have the night sky featuring in the nightscapes, but also some type of a foreground object. And I'm just thinking of Bob here. So right now we're looking at these beautiful live views through the Canary solar scopes of the moon. I'm looking down at my monitor and I can see the beautiful detail. And when I think back to my first experiences photographing the moon, one question that comes up is why do what do I like about what do I like about and enjoy about photographing the moon? And I think back to some of my first experiences back when I was teaching astronomy, and I would take my class out on the night of the full moon, or even better, the night before the full moon, and have a chance to get out on a hillside and get a clear view of the western horizon when the sun is setting, and the eastern horizon where the full moon is about to appear. And we would just wait, and the sun would set, and we'd have these magnificent sunsets colors. But then all of a sudden, at some point after, shortly before sunset, or right at sunset, or shortly thereafter, we'd all play a little contest. Who can see the full moon rising over the eastern horizon the first? And that's one of the best things I think about it, is that, as you can see in this graphic that we're having a chance to look at here, this is an example when the moon was actually, this is the day before the full moon. So there's sort of the waxing gibbous moon, 99.5% illuminated or so. And what you can see is when the moon first becomes visible in the upper left of this graphic, you can barely see it. It's hidden in the clouds. And that's because the brightness of the moon is overwhelmed by the brightness of the sky. But then a few minutes later, you can see, I'm moving the tripod around here in this graphic, number 2, you can see the moon, you can start to make it out through the clouds. And then in number 3, I've added a colored filter. You can really start to see the moon in the civil twilight. You can start to see it shining through the dusk. And then 4, 5, and 6, as twilight deepens and fades away into night, you can see the moon standing out like a spotlight. And so this is really one of the first pieces of advice I give folks when they're thinking about photographing the moon is, especially when I say the moon, I should say the full moon, is that the timing is absolutely crucial if you're interested in photographing the full moon. And actually, there's only about realistically a 15 or 20 minute interval. That's it, 15 or 20 minutes to capture the full moon before it's either washed out by the sky or it's either overwhelmed. It itself overwhelms the rest of the night, as Bob was talking about with Helen's question with Earthshine and moonshine. Oh, Paul's back. I'm going to stop. Welcome back, Paul.
Thank you very much, Mike. You're a doctor. You're into physics and stuff. What do you know about the way a first quarter moon affects electronics and networks and stuff like that?
Oh, there's a very high correlation, especially with astronomers in the Canary Islands, that there's a nearly 100%. There's a special elementary particle that's known to only occur on that phase of the moon. That, oddly enough, with that coincides with the presence of an astronomer, then it tends to knock out that it's really it's a well-known phenomenon, Paul, and I appreciate your
It's
volunteering to demonstrate that for us tonight.
Thank you very much. I mean, I wish I'd known about this gremlin particle beforehand, but I mean, we have never, like, we have never had a failure like this, and for it to happen 1 minute before the start of a show, and
That's
you know,
extraordinary.
if I was in that dome, I could kind of understand if I kicked something or anything like that. But anyway, you have been explaining um, how to photograph the moon. So I don't know how far you got, but what tips have you got for our pros out there?
Absolutely, Paul. Great. Well, thanks for asking. So, again, kudos to hanging in there because it's really quite a whirlwind. So, for those interested in photographing, especially the full moon, but also the crescent moon, these are the two phases of the moon that are really of interest to the Nightscape community because these are the phases that really most easily are photographed adjacent to a foreground during sunrise or sunset. And for a full moon, the main piece of advice I would say would be to get out the night before the full moon or the dawn on the day after the full moon. The day of the full moon itself is kind of a bust because the moon is often in the sky when it's still pretty dark, and the brightness of the moon is just too much for the foreground. In other words, at sunset, it's become dark and the moon starts to rise, and it's so bright that it's impossible to get a single exposure with with both of them in place. The other piece of advice I would really urge people to think about, and this is what I tell all my participants in my workshops, is to do a series of exposure bracketing exposures. And this is where you sort of vary the shutter speed over an enormous range of shutter speeds, plus or
Okay.
minus 3 or 4 or 5 stops. And one of those is guaranteed to work. So those would be my two off the top of my head pro tips.
Mike, can you use that same tip of bracketing to capture earth shine?
Absolutely. The same applies to the waxing crescent or the waning crescent moon. And this is especially for a very young moon within a few days of the new moon. And it's sometimes possible to apply the bracketing technique where you essentially have an exposure that's optimized for the earth shine of the moon. The shadowed portion of the moon is now receiving the earth shine, but also the directly illuminated crescent portion of the moon, which is so much brighter. But by having exposures optimized for um, both of those subjects, it's sometimes possible to combine them afterwards in Photoshop into a single image where both are optimally exposed, and the results can be absolutely spectacular.
Are you going to cover any of this? It would be really cool to cover some of this on next week's Nightscape audio show. Are you going to follow up on this with some more moon tips?
You're reading my mind, Paul, because I was thinking just the same thing. That why don't we have
Great.
our upcoming Nightscapes live cast, which is on Tuesday nights at 9 p.m. Eastern Time, 0100 UTC on Wednesday morning. And yeah, let's have that be a moon Nightscape special show because that's something that
That'd be
we get
great.
lots of questions about, and there's lots of discussions because, as Bob and Helen were both saying, this is such a common object to see. It's easy to photograph actually because it's so bright compared to everything else. But the results
Yeah.
can be disappointing. I think there's a social media post that shows an image like we're seeing on your live view of the moon. This is what we in our minds. This is what we see, and then there's an image of what we actually photograph, and the moon's a little white dot, and it can be jarring. But let's do that for next Tuesday. Great
Yeah.
idea.
Actually,
Like that.
I was going to talk about this in the intro to the show that never actually happened. But, two things there, Mike. One is, out of all of the shows of the year that I was looking forward to, it's this one. And I'll tell you why. It's because we are so familiar with the moon and we rarely cover kind of regular things at Slooh. We do an asteroid that's whizzing past or a
Right.
special transient event. And what I love about International Observe the Moon Night is that it gives us this opportunity of reacquainting ourselves with this incredibly familiar object. And certainly for a lot of Slooh members who use the telescopes, they curse the moon because it makes the normal images of nebulae and galaxies and star clusters and stuff like
Right.
that quite noisy. But to me, I was so looking forward to this tonight. And as soon as I came out of the residence to come up to the domes, the moon just looked so
Oh,
white. It was absolutely incredible. And I'm looking out now. I mean, I'm looking at screens here, but I just look up to my right, and what I can see there is that first quarter moon. And for anybody, I urge anybody who's watching tonight, if you have a clear sky, as soon as darkness falls tonight, what I can see just above it is a little yellowish dot, Mike. I don't know if anybody's talked
nope,
about that in the
not
show,
yet.
but what is it that people can see up there? Because it's a real treat tonight, isn't it?
It is a treat. And I'm remembering the image you posted. And this, of course, is the ringed planet Saturn, which is, of course, has nothing to do with the moon, but just from our vantage point tonight, you'll be able to see this is a sort of a planet-moon conjunction. And it really is striking because this, like so many other things of astronomy and just naked eye observing at the night sky, allows us to appreciate the three-dimensionality of what we see, even though it appears as this two-dimensional image. And it's just a striking thing to imagine just zipping past the moon and then whoop, over to the planet Saturn. And then, of course, we have Jupiter if you're at the appropriate latitude. So it is a great time to be observing. And I share that also, that this is such a great experience because as Bob started off, the very first thing that Bob showed this evening was a pencil sketch that he'd drawn when he was, I think, 10 or 12 years old. And it has that appeal to anybody of almost any age.
Yeah,
We have a young daughter and she
exactly.
is always looking for the moon in the sky. And it's even, anyone can see this. So just
Yeah.
definitely it's well worth seeing.
And people don't realize they can see it during the day as well. But look, I don't
Right.
know if anybody's mentioned this as well, because this is something that we lined up especially for tonight as well. This is the
Oh,
Canary
here we
3, which is
go.
just behind me. So it's not
Nice.
just, so only Slooh will do this. So everybody else who's doing an international observe the moon night is only going to show their viewers or their guests one moon. But
Yeah, they
we're
didn't say
showing
which moon.
people 5 moons. Exactly, they didn't. So, Mike, explain what we're seeing here.
Oh, well, this would be a great thing for, we had some, Bob and Helen were talking about the naming conventions for the different mare, the Maria and the craters and the various others, the peaks on the moon. And of course, Galileo would be very happy to see this because this was the observation. These are what we're looking at here is a telescopic image of the planet Jupiter and 5 of the Jupiter's moons that are so bright, the Galilean moons that are visible so clearly because they are so close and so massive. And here's the thing for those interested, especially if you have a pair of binoculars or even a small telescope. We were doing this last week. I was doing an astronomy training program, and each night we would go out and literally just, sketch how these Galilean moons appeared relative to the planet Jupiter. And on successive nights, this is just 24 hours apart, you can go out and see visible rearrangements of these moons. And it's just one of these nearly naked eye observations that is literally mind blowing because this is the observation that Galileo based his conclusion on, that in fact the Earth is not the center of the universe.
Yeah.
And of course, lots of stuff happened after that. But nonetheless, this is a very, very nice view on
Yeah.
our inches.
Well,
We have an international Observe the Moons night.
exactly. We don't usually use this Canary 3 deep sky scope to image planets because it's so sensitive. But the reason why I set this up with these special missions, Mike, is precisely what you're saying. This is replicating exactly what Galileo saw through his telescope in 1609, 1610, whatever it was. And what we can see here is the bright one right in the middle. That's the planet Jupiter. And then from left, the little white dot, he described this as a string of pearls, didn't he, on either side of the planet. And on the first night that he observed it through his telescope, there were only 3 small dots. But the following night, he saw 4. And what we're seeing here is Jupiter in the middle, the moon to the left, that's Europa. The moon closest to the planet to the right, that is Io. Now, that's the one that orbits really, really close. And it moves over a period of minutes. You can watch it. Then the next one out is Callisto, and then the furthest one out there is Ganymede, one of the largest moons actually in the solar system. So anyway, that's why we added this one in. So Mike, I don't know. We should probably take one. I'm just going to move the Canary
Yes.
4 telescope bit, because this is an absolute treat, this live video stream. And what I did with this one, you probably won't approve because you're an absolutely classic and brilliant astrophotographer, but what I did with the camera here, Mike, is I turned the saturation up quite a bit. So
That's okay, Paul.
this is you can just see there's a little bit more color than one would normally see
I see. Yes.
in the moon. And now what we're going to do with this, Mike, a little bit later on is I'm going to take some recordings using this camera. So just like
Okay.
this, because members were asking if they could do any lucky imaging
Yes.
from the video. So I don't know how much I know you know loads about lucky imaging. Can you give a really brief synopsis for somebody who doesn't know what lucky imaging is? What's that? And we can end the show on that note, I think.
Okay, very good. Well, as always, Paul, my mind is filled with lots of tangential topics to talk about. So I'm going to try to channel onto this. I'll just say that when we concluded the observations of the Jupiter's moons, I think what Slooh has done here is to take the international Observe the Moon Night and turn it into an interplanetary Observe the Moons event. So congratulations on that. And so the lucky imaging, again, this is something really that I've only dabbled with in the past, but the basic premise is that any observation we make from a ground-based observatory is, of course, peering through the Earth's atmosphere. And we've all watched the stars twinkle at night. And in fact, if you look at some of the brighter stars like Sirius, for example, if you study them, it's almost a kaleidoscope. You can see a little glint of red or a little glint of blue. And lucky imaging is basically based on that premise, that if you're looking at a recording device, a video device, which is recording, let's say, 24 or 30 frames per second, one of those frames is the winner, because at that particular moment, the atmospheric conditions align and you have total clarity. And so by scrolling through these dozens and dozens and dozens of images, occasionally you can stumble upon, I won't say there's no science involved, because there's a lot of science involved, but there's a certain amount of luck in this, and that's where the fun is. You're hunting for that. It's like an expedition where you're hunting for that trophy image buried amongst all the non-trophy images. So it's a lot of fun. And if the right one appears, boy, it's a good one.
And then, of course, what you can do is you can collect together all of those best images. You can combine them, and that increases the quality even more. But what viewers might, if viewers are going to go out tonight, you can actually see the moon.
Paul, call Earth calling Paul. Earth calling Paul. I think we had some lucky imaging with Paul there for a few moments, and hopefully Paul will be able to rejoin us. But this is for those of you who are still with us, this is the essence of astronomical imaging, is that there's a lot of things that can go right and there's a lot of things that can go wrong. But certainly, I know Paul's going to be gnashing his teeth with this, with the lucky imaging. But certainly that is something that's well worth trying. And as Paul mentioned, the other Slooh viewers are able to capture some of this footage and go through the footage and extract the relevant frames and pick the best ones and then combine them together. Are the ones that are best advised to do just that. So I'm just going to check to see here if I have any other direction. Okay, but I think, you know what, folks? So thank you again for joining us this evening. I thought we had a great discussion with Bob. I've always learned, I'm now going to, every time I think of coyotes howling, I'm going to think of oxygen howling and oxygen. So that's something that sticks in my mind. And then, of course, Helen's discussions of the mapping and the some of the history there with stuff, and hopefully with the discussion of the Nightscape's photography that inspired a few people to try snapping some images of the moon, because it really is something that is relatively easy to do and can be just magnificent. And plus, 90% of the fun is just being out there. So with that, folks, again, this is my name's Mike Shaw. I'm host of the Tuesday evening Nightscapes live class. We have a Nightscapes club. You're all invited to join and participate in the discussion. We have a great group of folks who are constantly posting images and questions and ideas. And as Paul suggested, our Tuesday night show will, I'm sure, be dedicated to moon photography. But in the meantime, as Paul mentioned, get outside and look at the moon if you can tonight. It's right next to Saturn. You can see Jupiter. You're standing on the planet Earth, so you have 4 solar system objects right there at your fingertips. And we hope you've enjoyed the show. So with that, I'm going to.
I don't really like these arbitrary.
I'm going to wish you. My phone just decided to talk. So with that, have a great night, everybody, and thanks so much for joining us. Take care. Bye-bye.
Slooh is your interface to space. Online telescopes situated on mountaintops around the world await your command to schedule missions so you can capture images of the 1,000 most intriguing celestial objects in the universe. From just $20 per year.